will hold a student council meeting for everyone who wants to be a part of student council. It's open to anyone interested in throwing out their ideas, kind of working together, planning things as we kind of make it through whatever this particular homecoming week looks like coming up very soon. So check your email, and I'll be making probably some more announcements about that. So thanks, everybody, and have a great day.
All right, hi, everyone. Happy Monday. All right, so I thought we'd just take a second to look and see the status of the Junco. I did get a text from Chad this weekend, and he was at a place called Ross Run in Wabash, kind of near Hanging Rock. Saw a bunch of warblers, so I was totally jealous of that. So if you remember before, we were just mostly in Cleveland and mostly up here in northern Michigan, but it's gone a little bit south. We've got one in Ann Arbor, now one in Columbus. Okay, so we shall see. It is slowly getting closer and closer to us, but I do not expect it anytime this week, but you never know. Okay, today is the 14th, right? 14th. So, yeah. Whew. It'll be interesting to see what happens. All right, now listen, we're going to try something today, and it could be a complete and utter failure. I've never tried it before, but I want to try it because I found this thing and I got excited about it. So I would like to try us together. Okay, but I want to do a little quick review. Okay, on Friday we talked about this trophic pyramid, right? With some terms that we've been using before, like producers and consumers. Are we producers? No, because we don't make our own food, right? Give me an example of a producer. Oh. Plants, right? And when we did that food web, what was the plant that they chose? Algae, right? We talked about our own little situation, and we started off with grass, right? And then cow, and then human, and then, well, who knows after that, right? Okay, so we're consumers. We're not autotrophs. What's the opposite of an autotroph? Looking for a word that starts with an H. Heterotroph, right? We get our food from other places. All right, I need everybody to open up their Chromebooks, put your other computer away there for a while, your Switch and all those things, right? Okay, and go to Google Classroom. We're going to do a little simulation here together. Let me get my microphone on too. If you're at home, okay, watching from home, I would like for you to do this too. I will give you class participation for this, and hopefully we'll have some good success. Have you seen my microphone yet? Both about microphone. I feel cool. I feel like like very professional, for all those in the back. Come here. Oh, if you could all take your seats, please. We will be departing in approximately 5 minutes. If you would put your seat backs in the upright position, your tray tables up, please. And we'll be taking off. Unfortunately, because of the virus, we will not be providing any food service today. If you need some help, please press the button above your head. We will be circulating the air throughout this cabin. Hopefully, there's no virus in the air. If there is, we're all going to get sick. Very, very, very sick. All right, so go ahead and open up the simulation. Sorry, that was ridiculous. All right. And it should look like this on the page, right? Everybody got this? Everybody see this thing on the Googles, on the classrooms? Okay. You charged up? Justin, you need a charger? Okay, I got one for you. All right. So I thought this was pretty cool. Actually, the folks that run this, I know a couple people. One is my professor in college. He's a part of this. Another guy is a Manchester grad. Well, you might know Paul Strode. You remember Paul Strode, Melissa? He would have graduated in probably 86, maybe. Oh yeah, 87. All right, so I think he had an older brother, Kyle, a younger sister. I can't remember her name. All right, click Launch Interactive, okay? And hopefully, fingers crossed, this is going to work. We're going to do like a little online research. So there's a little button that says Launch Interactive. Click that. This window should pop up. Okay, there's hopefully a bar going across. Okay, good. And we'll see what happens here. All right, so yours should say, because I practiced this a little bit on my phone, yours should pop up with some words, right? Don't click next. We're gonna read this stuff kind of together, okay? Because I want to make sure that you get this, and everyone's is going to be a little bit different, okay? Everybody at this window, we got this. Everybody good? All right, let's take a gander. Let's see what I can do here. Oh yeah, hit enter. Yep, good. Fantastic. Good. Yeah, help your neighbor. Oh man, you guys are. I'm so thankful. I have such a great first period class. Okay, so let's just read this together. It says, what determines the number of deer in a forest or fish in a pond? Energy or food availability has a lot to do with the number and types of organisms in a given habitat. Okay, so click next. Guess why I like this one so much, huh? Yeah, great blue heron right there. How does energy flow in ecosystems? Most life on Earth depends on energy from sunlight. Remember, ultimately, all of our food comes from the sun. Plants and other photosynthetic organisms convert this energy into chemical energy that they need to grow. Energy is transferred when the plants are eaten by organisms who also get eaten in turn. Ecologists call these steps in feeding relationships trophic levels, just like those on the board, right? Okay, here's an example. The lowest trophic level contains producers like grasses that are eaten by primary consumers, grazers, which are in turn eaten by secondary consumers, predators, and so on. Typically, only about 10% of energy stored in biomass at one trophic level is transferred as energy to the biomass at the next trophic level. Ecologists typically represent these relationships as pyramids, showing either biomass or productivity levels. By determining all the players in a particular ecosystem and their interactions, who eats whom, ecologists can make predictions about the amount of biomass and productivity at different trophic levels and under different environmental conditions. In this activity, you will study trophic relationships in the Rio Frijoles, an aquatic ecosystem in Panama. In this system, the primary producers are algae, and the primary consumers are grazing catfish. Any fishermen out there, fisher peoples? Okay, catfish. You gotta be careful of that barb on the back, right? Okay, you're gonna predict the number of catfish that live in the river based on the productivity of algae they feed on. And we probably will not do number 2. So go ahead and click Launch Field Study. And so get to this, you might have to turn the sound off if your sound is on, or if you got headphones on, there's a little bit of like trickling stream sounds. All right. Welcome to the Rio Frijoles field site in Panama. It is a great day to enter the stream and study its inhabitants. The Rio Frijoles is a stream that consists of small pools linked by shallow riffles. The pools are home to algae grazing catfish and attached algae that grow on rocks. This panel serves as your lab notebook. And by the way, you are going to type some stuff in and you are going to download that and send it to me, okay? So that's kind of like this You'll see here in a second at this top, I can click this away. I can just see the picture. Okay, you don't want to click this yet. That's going to send me your kind of your lab notebook. You'll see that in just a second. Okay, here you will receive instructions for the lesson, collect data, perform analysis, and answer questions. Click on the icon to open and close the notebook. Okay, I guess you could do that now. Please enter your name. I'm putting Javen. If you could put go ahead and put your first name and last name. I'll put Javen Burnworth. There we go. And boom, that is your lab notebook. So it will look like this. And then you can click, you were asking where we were at. Oh, did it not pop up? No. Turds. Okay, hold on a second. When you click that upper thing, what do you get? So when you click that, the arrow up, the box with the arrow up. There you go. Click the box with the arrow up. That's where you enter your name. And if you do first name, last name, that would be awesome. Okay, first name, last name. Everybody got that? Any questions? Okay, cool. Yeah, okay. There it is, right there. So click that again. Click that. There you go. Okay, and so that's your live notebook. You can click out of that window. It will continue to save this for you. What's that?
That's magic.
Okay, great. Thank you so much. Look how pretty that is. Look at that ball. Go
to a different window.
Magical.
Okay, any questions? Any questions about this? All right. So it says, to begin, explore the various pools of the Rio Frijoles using the map. Note that you can zoom by using the plus and minus symbols in the lower left corner. After exploring a couple pools, click the commit to pools. All right. Now I debated, so you have to you can click on each one of these different pools. Okay. You can always click this 3 bars at the top and make this go away. You can click all the different pools. You can look at those. I debated saying that we were all going to get the same pool. Okay. But let's try it. You pick a pool and then say commit to pool. Yeah. Okay, cool. So go back to, you go up at the top. It's going to be in a separate window. So when you get out of a full screen, no, not that. It should be, what's that?
The thing that has the box with it.
Oh, there you go. Box and 2 lines. Yes, put that. There's your other window. So if you can't get back to this, it's the box things. This is the stuff I don't realize. The box and the 2 lines at the top, it'll get you. Because this simulation automatically opens up into another window. Okay? So you have 1, 2, 3, 4, 5, 6, 7 different pools. Once you find a pool, commit to that pool. Did yours go away? Okay. All right, that's weird. Let's go. One or two exit out of it by accident. Go explore biomes. So you can launch interactive. And then it should say resume.
It didn't do that for me.
It didn't do that for you? Okay.
I just exited that.
Okay. Scroll down a little bit. Okay, enter, and then skip intro. And then here you go. There you go. And so pools, now there you go. All right. Okay, cool. So everybody pick one. If you are like, I kind of want to follow Mr. Burnworth, I'm going to just go ahead and go bromeliad. Okay, and that's going to be my pool. If you want to pick that with me, fine. If you want to do a different one, fine. But I'm picking bromeliad. So if you're at home and you just want to follow along with me, click bromeliad. If you are like confident and you're like, oh man, I want to do this on my own, then go for one of the others. All right. What's that? Okay, so you just go back in. Okay, that's cool. Yeah, just skip picture. All right. So it says catfish in the Rio Frijoles primarily eat algae. In this ecosystem, the algae are producers and the catfish are the primary consumers. Ecologists typically model patterns among trophic levels by drawing pyramids. The name for these pyramids are ecological or trophic pyramids. One more specific type of pyramid is called the pyramid of biomass. This pyramid shows all the biomass at different trophic levels at one point in time. Because this ecosystem has only two trophic levels, algae and catfish, it can be represented with a two-tiered pyramid. What ideas do you have about the structure of the biomass period in this pool based on what you already know? Okay, so once again, this term biomass might be new to you. It would be like if I measured all of the biomass of humans in this room, I would weigh each one of you and then add that up. Okay, that's our biomass. Okay, not the entire biomass of the school, just us. Y'all with me on this? Biomass is weight. Of course, there we go. So catfish is here, here, here. Algae's here, here, and here. Which do you think, based on what we know from before, should we pick A, B, or C? Kenneth.
B.
Okay, nice guess. I'm going to pick A. Why A? Okay. Okay, sure. Maybe it's the least amount of catfish and algae takes a while to grow. Okay, there's another reason why I believe you should pick A. Nice guess. What's that? Okay, great guesses. Oh man, these are not what I thought you were guessing. I love the fact that you're guessing these things. Okay, cool. Yeah, you got it. It matches this. Typically, producers are the biggest, right? With the most amount of joules. Remember that rule of 10%? Okay, I just take away 0 and I get less and less as I go up. So typically, by definition, producers are always the biggest. Y'all with me on this? Yeah. Okay. All right, good. All right, so I'm going to pick A like that, and then I'm going to hit continue. Okay. So I'm going to put, for me, it matches the trophic pyramid on the board. That's what I'm putting for my justification. Okay, so if you could type in something like that, okay, it matches the trophic pyramid on the board. It matches the trophic pyramid on the board, and so now I'm going to hit continue. This is where the research comes in. I'll pause for a second. Thanks for sticking with me. You guys are the best first period ever. Okay. All right. So if you can kind of see in the background, if I click these 3 lines right here, now there's a little grid. When you get into AP Environmental Science, if you take that class, we will use grids like this in several different ecosystems, okay, and do actual research. So I'm going to click this back, and we're going to talk about algae collection. One question that may interest us is how many fish can be supported in a pool. Based on the pyramid model, we may be able to determine the total biomass of the catfish population that can live in this pool by measuring the total biomass of algae. The first step is to determine how much algae is available for fish to eat. You will measure the amount of algae biomass in a section of the pool you have selected. Dr. Power placed clean tiles on little platforms that grazers could reach and then measured how much algae grew over a specific number of days. In this virtual world, the grid located in your pool represents the tiles used by Dr. Power within 4 days of algae growth. By the way, this is all based on real research. Use the scraper tool to collect algae within the white gridded area located at the bottom of your pool. The amount of algae biomass will be automatically measured as you scrape. You will be able to advance once at least 75% of the grid's total area, that's 1 meter squared, has been scraped. Okay, so now you're going to use this scraper tool. So you just take this scraper tool here, okay, and begin scraping like this. Okay, so you got to scrape, and you can see over there on the left, it'll tell me how much I've scraped. I want to get as much of that.
It's not working. Oh, there, you have to click on it.
You gotta click and drag. Is that the way?
No, don't drag.
Don't drag, just click.
It'll turn pale.
Okay, cool. I want to get mine. It looks like most of the green is gone. Of course, we're going to have slightly different numbers based on how much you scrape and how much I got it. How much I scrape, right? Okay, and it'll tell you how much you scrape there on the side. Your fish. Yeah.
Mine doesn't work.
How do I scrape it?
All right.
Oh, you can zoom
Let's just
on.
try. Get rid of this thing.
No.
Yeah, the plus button will zoom you in.
It's still full. It looks like 6 minutes.
All right, now just scrape it like if you use, there you go. Let's see. You have to do like what? Okay, put one finger in. Okay, cool. So one finger there, and then you.
I scraped a lot. One meter. What? This is so fun. I don't get this.
Hey, tell me against me how I did it.
I just like push it down.
Uh-huh. And then it lets you do it. Oh. Let's go maybe out like this. Any other tricks? Gracie's having issues with her scraping.
How's the mouse?
What's that?
What are you doing? I have that smooth here for a little bit.
Weird. Okay, let's do this. Let's go X out of it and try this again. Hopefully it'll take you right back. Yeah. Everybody else get, oh, that's cool. Oh, you zoomed in. You get the fish. Oh, I didn't know you could do that.
1.0. Let's go.
Awesome. He's just doing the same thing with the scraping.
Oh, this looks shallower than it did on the top.
I get to mine. Oh.
I got it.
Okay, Gracie, hit resume. Let's see what happens.
Yep, I got it. I exited out and I did that.
It did, and it worked.
Yeah.
Okay, cool. All right, now get rid of these. Yes. Now scrape. Oh, it worked.
I got it without.
Okay, it looks like the key is exiting out and going back in, but hitting resume. Okay, is everybody done scraping? I know it's couple people, wait another minute here. And again, we probably will not get this totally done today, which is fine. Okay, but it'll save our progress. Okay, and hopefully that will keep it, at least for me, it kept it past a day. It remembers you. All right, the math stuff is kind of the hard stuff, but it's not too bad. So once you've got your algae set, okay, you click those three buttons and you say algae collection completed, okay? And now, sorry, I'm going through puberty here today. So it says using mathematical and computational thinking to extrapolate your measurements obtained from the grid area to the entire pool, determine the total algae biomass in this pool. Assume the area covered by algae is equivalent to 30% of the pool's surface. Okay, so you're like, oh, math, whoa, you didn't tell me there's going to be math. Click the calculator. That pops up. Then click the hint. The hint is key. You may have to write this stuff down if you can't remember a couple of things, and that's fine. It says to calculate the total biomass in the pool, determine the total area of the pool covered in algae, and multiply it by the biomass of algae collected per area. Okay, so you're going to take the pool surface area times 0.3. Here's the cool thing about this. I just click pool surface area, that's 64, and it automatically goes. I don't even have to type it. Then I go times 0.3, and then that's equal. So I'm going to remember the 19.2. Okay, if you need to write that down somewhere for you. Okay, but yours is going to be different. Okay, so you're taking your pool surface area. It's this last number. Okay, times 0.3. And then either remember that number or write it down somewhere, okay, that you won't forget it. Okay? Then, after that, you're going to clear that, and then it's biomass divided by scrape. So boom, divided by boom, okay? And I hit equal, and that's 0.21. So now I clear that. I'm going to take 19.2 divided by 0.21. Oh, that didn't give me 19. 19.2, hold on a second, divided by 0.21, and this is going to be my answer. I'm going to click use 91.429.
What happened?
What do we do for the second area?
Okay. Oh, did I mess that up? Oh, I hit divide. Sorry. Thank you. I'm an idiot. I hit divide there. Okay. I'm going to get rid of that.
So we take biomass.
You take biomass times, so that first number, sorry, thank you for correcting my mistake, to be 19.2 times, I divided there, 0.21 equals, and then that's what I'm going to use. Okay, for me. Okay, yes, thank you, geez. How do we do that? Okay, so let everybody follow me real quick. Okay, I just want to make sure, because I knew this was going to be the hard part. Okay, everybody start with this. Okay, I'm going to just hit clear. I'm going to get rid of this. Okay, so everybody, first thing you need to do is click on the button that says pool surface area. Okay, click that, and it should pop up in the calculator. Does anybody have an issue with that? Everybody got that? Now, multiply, so the x times 0.3, and then equal. Okay? And either write that number down or just remember it. Okay? Yes. Your pool surface area times 0.3. So you click this button right here, you click this number, whatever your number is, and it automatically goes to the calculator. Let me show you one more time. Stick with me here. Okay, so I click this pool surface area. I click that, it automatically goes in times 0.3 and then equal. Does anybody have any issues? Everybody got that one? Okay, so then I'm going to hit clear. Then I want this next part. Biomass, I'm going to click this, divided by area scraped. And I get this number, 0.21. Now I'm going to multiply that number times my original number, which was 19.2 equal. And that's what I'm going to hit, and I'm going to click use. Okay? Okay? All right. So now click the bottom number, 64. Just click 64. Okay, times 0.3. Yep. 0.3, yep. Equal. Okay, so you got 19.2. Now hit clear. Now take that top number and then divide it by the area scraped. Equal. Okay, now multiply that times 19.2, and that's your number. Do we all get the same number? Okay. Oh, yeah, man. So you just use those numbers. Use those. Okay. So take the same process as I did it, just use your number. Does that make sense? Yeah. So you take that point, or the 28 times 0.3. I mean, yeah, that looks like a valid number. Okay. All right. Is everybody good? Oh my gosh, you guys are amazing. All right. So all of you, so if you didn't hit the word or that button use, everybody should have that number in there. Everybody should have that number in there. Okay. I mean, not my same number, but like you just click the button use and then boom, there you go. Okay. And then hit continue. Okay. All right. Now, let me read this, and hopefully we can do this in the last 2 minutes. You now have estimated, okay, you now have an estimate of the algae biomass in the pool. Remember that your goal is to determine how many catfish can live in this pool. Ecologists estimate that about 10% of the energy stored as biomass in one trophic level is used to produce biomass in the trophic level above. This is sometimes referred to as the 10% rule of energy transfer. This rule allows you to make predictions about the number of organisms that can exist at different trophic levels in an ecosystem. Okay, using the 10% rule, calculate the amount of catfish that can be supported by the amount of energy. So go ahead and click the calculator, click your number, and then multiply it by 0.10. Okay, that's the 10%. Okay, it automatically does it for you. And then hit enter or equals, and then click use. Okay. That'll give us our 10% of that amount, right? Any questions about that one? So if I took, for example, if I took 10,000 times 0.1, right, that would give me 1,000. Okay, this will save for tomorrow. Thanks. Didn't know how long this would take. You guys are the best. Have a great day.